All right. A couple of you have been to some of the other kind of 4 geographers talks that John and I have been putting together. This is a new one for this year. We decided to focus on kind of a really nice introductory level kind of JavaScript for people who have never really seen JavaScript before. And if you want to get the slide URL, it's right there. We'll show it again at the end. So if you don't get it right here, it's totally fine. And kind of, we laid out a little bit more structure and agenda on this one than some of the others. So we've got some basic fundamentals that we'll show you, just some basic kind of JavaScript, the programming language, a little bit about how JavaScript works, and then hopefully kind of get you over the hump on some of the things that tend to catch people when they get started really fast, and then you'll run into something and you have no idea how to solve it. We'll go through a few of those. We'll do a little bit just about building web applications in the browser, so just introduce you to some of the concepts that you'll see when you're building an app in the browser. We'll talk a little bit about the JavaScript API, and then we'll kind of talk about what originally made me want to do this talk, which is JavaScript fatigue. So I've been a JavaScript developer for probably like 7 or 8 years, and in that time, JavaScript has completely exploded. And there was an article kind of late last year when we were planning out talks for Dev Summit that's what it's like to learn JavaScript in 2016. And I've got a quote from it later, and it just lays out, there's someone coming back to web development from maybe like 2012, and they're trying to learn 2016 JavaScript, and they're just like, it's just all these tools, and it's completely bewildering, and there's so many concepts, and there's so much of this stuff, and there's not a good kind of back to basics approach to ignoring all of that and focusing on just kind of learning the fundamentals so you can start building apps, and then you can get in to some of the more complex stuff. Because without that really solid grounding in the fundamental stuff, all of that's always going to be really confusing. So we want to talk just a little bit about that. So kind of feeds into this. JavaScript is a big, scary place. There's thousands and thousands and thousands of programmers. There's hundreds of libraries and modules and frameworks and everything, and it's this giant beast of a thing to try to learn. It's not like learning .NET development where there's one editor. You always use Visual Studio. You always use the same library. You always use the same editor, the same test framework. You target the same devices. What was that?
That was like my most epic interruption ever.
Dang, that was good.
You still have time. That wasn't like me cutting you off.
No,
I was like,
I still have time.
I was listening too intently.
So this session's kind of intended to be the guide post for you to say, it's okay. If you don't know all of that, it's fine. I don't even know all of it. I never touched React until I had to do a demo this year, and then I only did like 10 lines of it. So it's okay if you don't know all of this stuff, because no one knows all of it. I don't know all of it, and I do this 10 hours a day, 6 days a week because I love it, and I don't know everything. So it's fine if you don't know everything. So we've got some basics, confusing part, get the guide, how not to be overwhelmed. So I'm going to pass it over to John.
So Pat and I both, Pat's classically trained as a designer, and I'm classically trained as a geographer. So we're both hacks in that we learned programming after the fact. And we know that a lot of folks that come to Dev Summit, some of you guys are doing moonlighting, trying to do a little development on your own. You primarily do a lot of GIS analyst work or some other type of work. Some of you guys are working on a team with developers, and the point of this talk is to introduce some concepts so you're just a little bit more conversant. And there's some links we're going to share if you want to learn more. But it's just getting familiar, getting your bearings. And for me, it's important. When I really started programming in JavaScript, there was initial hurdle of thinking that it was this incomprehensible, like only magicians are developers and GIS analysts are just regular schmoes. As a GIS person, you are already equipped to beat your head against the computer, to try different things, to have a troubleshooting technique and mentality that's going to help you learn some of the stuff. Some of the concepts in GIS of data types and geoprocessing tools, there are similar or correlatives in programming. So you're much better equipped to learn this stuff, even if you don't know it yet.
There's seats in the front if you want to come in.
Yeah,
the
come on and
sound
get cozy.
gets better. Some people are like hiding behind the wall now. They're like, oh no, he saw me back here. So you come forward. There's like seats in the front. It's
All
fine.
right. So that's the setup. Now let's get into it. Let's just talk about some JavaScript. We're just going to take it for granted that you're interested and that JavaScript is a powerful tool that everybody wants to learn. If you don't, we just assume you have your reason. So let's just do some JavaScript. I'm going to squash over. Is that text big enough? You guys all right? So the core fundamental sort of concept in JavaScript and in other programming languages is this idea of variables. Defining a placeholder, a word that's going to have a reference to something else that might change. So the end-all, be-all JavaScript from the good old days is always var. You say, my variable is whatever you want it to be. And the new stuff that you see in the brand new JavaScript is let or const. Those are all, for all intents and purposes, they represent the same thing. You're declaring a variable. And when I do this, I can do this here on the side. I can write JavaScript here in the console of Chrome or any of the other browsers. If you open up the developer tools, there's a interactive opportunity to write JavaScript and see some of this stuff in action without having a text editor open or anything else. But this idea that when I declare this variable Pat, I still haven't defined anything. Pat could be anything. So declaring a variable is the first step, but it doesn't accomplish anything more than saying there's going to be something here stored here later on if I actually do that. So the next step is actually defining a value to be stored in a variable. Some variables are the same value forever. That's why const came out, this idea of a constant variable. Some can change, but the easiest way to not only declare the variable but define the value that's associated with it is to just use an equal sign. So I say var pat equals a friend. We're sticking with the theme from last night. So at first, Pat's undefined, but if I say Pat again, now Pat returns to me friend. Pat's a friend. And the thing that differentiates JavaScript from some of the other programming languages is you don't do anything explicit to make sure that Pat is going to be a text value or an integer or a floating value or a Boolean. So, as a GIS person, the correlation is like defining the data type for an attribute column in a feature class. This is not as rigid of a structure. And in some other programming languages, you define explicitly that Pat has to be a string. And if anybody tries to make Pat anything else other than a string, it's not going to work. Some people like that about JavaScript, some don't. We're not really going to get into the opinions. This is just the way it is. And knowing how it works is all that you need to do at this point. So from the variables, we've got operators. And I showed an example where I have a variable, but I'm going to show some other examples where we're just dealing with tangible stuff. And this is the same kind of stuff you'd see in the field calculator in ArcMap, doing arithmetic and doing simple math, saying 2 plus 2 equals 4, having a logic for doing arithmetic is something that you'll see in other people's JavaScript code. You add things together, you subtract, you divide. The thing that I'd want to sort of bring up about this is the amount of math that I thought I was going to have to learn in JavaScript versus what I actually ended up having to know was a lot less and a lot simpler. Doing arithmetic versus some complex calculus. That's not to say some JavaScript developers don't do a lot of heavy math, but you can get away with it. If you're a math person, that's okay. If you're not a math person, that's okay too. So here on this tip here, the only other one I'd highlight, you can add numbers together, obviously. You can also add strings together, and that's just concatenating the strings. If you have one string and another one, we slap them, and we turn them into a new string. And then that x plus plus is what we call an iterator. That's saying x equals x plus 1. So if you want to increment and count, you can either increment with a plus or decrement with a negative sign. So comparison operators. So the equal sign is for us defining and declaring to say, this is going to be equal. You're forcing something to happen. The comparison is, and I'm only going to show three equal signs because there's people that are going to say, why use 2 or why use 3? 3 says, test and tell me whether these two things are equal to each other. So you're just doing a check to say, is this thing the same as this? And when you have variables and you don't know, you're going to check sometimes to say, hey, is 3 equal to 3, or is my variable Pat, is it equal to friend, or is it equal to something else? Because I had some logic here. So we have, in the comparison operators, an equality check, an inequality check, and greater than or less than checks. So you can have greater than and equals to, or greater than. Not all of you guys have done this, but I'm assuming quite a few of you have done this in the context of like a definition expression on a layer where you want to filter and get only return to me a subset of the data based on a SQL clause. The SQL expression syntax and the JavaScript syntax are similar. So next, we've got logical operators. And you see these in a lot of people's code too. This idea of testing for conditions, and when you don't just have one, you have a few. You say, I want to test, are two different things true at the same time with a double ampersand? Is it sufficient, does only one of these things have to be true? You do that with 2 vertical bars. Or is something not true? And you do that with an exclamation point or a bang. So I'm showing you guys a ton of stuff fast. There are links throughout the slide. All of these things are links to either MDN resources. There's a lot of good resources out there to look up. There's conceptual documents and reference material. As long as you ever write JavaScript, you will keep Googling these things to remind yourself that's not
uncommon.
That's the way it's supposed to be. So next we've got arrays. Is there anybody, you got any Python folks in the audience? So if you guys have done Python work, what is the equivalent construct in Python?
I think it's still just arrays.
A list, or sometimes you'll say a dictionary. So this idea, I think sometimes people talk about tuples as well.
Yeah.
So this idea that you have a collection, it could just have one item in it, it could have a million items in it. The array, these square brackets, is the syntax in JavaScript for a group of indeterminate size. That array can be an array of strings, numbers. You can mix things up. You can nest these things pretty deeply. It doesn't matter what's in the array. If it's in square brackets separated by commas, that's the array. So dogs is an object that is an array, and if I want to dig out an individual item from that array, I'll use its index position. And arrays are zero-based. The first item is the 0th, I think people say.
Starts at 0.
Starts at 0. And that's that syntax of, if I know that dogs is an array, I can put the brackets afterwards and then identify that index. And if I want to push a new item in that's going to be tacked onto the end, I can say dogs.push. So there's a method, because an array is a native JavaScript object type. The tricky part here, at least for me anyway, the thing I forget once in a while, is length is a property of an array. It tells you how many items are in there. So even though the array has 0 as its index position, length returns to you the number of items. That's not based on 0. That's based on 1. Like, it's a count. So if we've got people scratching their heads, fair enough. This is also what the world of JavaScript is all about. There are talks out there that'll try and make you think that JavaScript is a completely illogical place. It's not that bad, but there are some goofy things. Next, we've got functions. Now we're getting into some of the other sort of core elements of what make up the JavaScript landscape. And a function is basically a execution, like a script that says, execute a particular set of JavaScript, whether you're doing some conditional work, some math, or just some string work. And usually a function will return something. So you call a function and the function returns something back to you. A function doesn't have to return something, but that's a pretty common pattern. So in this case, I've named my function dog years, and we pass in an age. So when I call the function dog years and I pass in an age, hopefully it's going to be a number. Then I can call age times 7 and I can get the people years, or however it works. So the important point to note is if I wrote just the function in JavaScript, I'm just saying this exists. The line at the bottom, dog years 3, calling a function is different than defining or declaring the function, and a function doesn't run unless you call it. So knowing that you wrote the function and then actually executing the function is something that you do in 2 different steps. We've also got anonymous functions. You'll see these quite a lot, where if you're not going to be calling the function over and over again, sometimes it's not worth giving it a name, using a variable to refer to it over and over again. You just say, here's a function, it's anonymous because it doesn't need to run any more than once. In this case, I don't have age, so in the parentheses, I'm not passing anything. That doesn't have anything to do with whether the function has a name or not. This is a concept of some functions accept arguments where you pass input parameters to them, and some don't. And if you have a need for one, you use it, and if you don't, you don't. So the corresponding concept in GIS, I always think of like GP tools. Some of them you just run, and some of them you have one input parameter, you set up the parameters, and then you run the function. So to me, a GP tool is my frame of reference for how I think about functions as well. And we're getting close to the end here, at least for my little bit, this idea of objects in JavaScript. And an object is, the syntax for it, or what we call an object literal, is these curly braces. And this is basically just all of the things that we talked about before, but nested. So when I say dog isn't just a string, but it's an object, that means I can nest properties inside of dog. So if I want the dog to have a name, if I want the dog to have some values, I can set that up inside. And in this example, I use shush, some top secret string property. That's a convention in JavaScript to denote private properties. That doesn't really mean that they're private. If you use your own code and introspect, you'll see the shush property is just as visible to people as the other ones. It's just like a honor system.
Yeah.
I don't know how you'd say it.
It's the honor system of JavaScript.
So that's an object literal. That's just, so far everything we've been doing is just what you can do with JavaScript in the browser, like the language all by itself. The power of JavaScript really is this idea you don't have to write all the code. You use an API or a bunch of APIs, and they make it easier for you because they wrote a lot of JavaScript that hopefully you just sort of reference and works for you without you having to dig into it.
Do you want to close out your console?
Yeah, since I haven't done, yeah, that's a good idea. I was going to do more with the console. I figured freehand typing's probably ugly for me. So in this example, same thing. Spot is an object, but in this case, we instantiate it. We use an API. So because we have a script tag that lets us know, it gives us some help with dog stuff, then we can say Spot is a new dog, and automatically there's a property set called can bark, and that's set to true, and that came to us from the API. And then I can still set more properties myself. I can say spot.age is 21 after the fact and give it some more properties and customize it. So that's this construct of classes and objects. The dog is the class, it's abstract. Spot is an actual dog. Spot's the object and dog is the class. And besides just properties, objects can have methods, and these are these functions that I was talking about before. So when somebody writes a function and associates that with an object, so calling geometryengine.buffer, that's executing a function. But usually, you don't always have to write these functions yourself. You just rely on the fact that the API did all the work, and you read the documentation, and when you realize, I want to do a buffer, it tells you if you want a buffer, pass a point, then pass the value of how big the buffer you want, and then what unit you want. So you guys have seen this stuff before with GP tools, and it works more or less the same way in JavaScript. 2 more. I got loops. So looping through lists, whether if you have 1,000 items to go through or something else, the syntax for loops in JavaScript is a for loop. In this parentheses, we define where we start, where we end, and how we increment through that loop. So in this case, I loop starting when I is 0 all the way until as long as it's less than 6. So I go from 0 to 5, and I increment I 1 at a time, and then I just log it to the console. So this is looping through, and the syntax is the same. It's okay if you got to look this up when you're ready to do it.
I can't write that by hand. I have my text editor. I type 4 and hit tab, and it puts the rest of it in there for me.
I can, but every time I do, I use a comma instead of a semicolon, and it doesn't work. So Either way. So here's looping through an array. Same concept. We start with I being equal to 0, and then like I said before, we can test the array length, and even if we don't know how big that array is, we can loop through all the items. So in this case, you want to use less than and not equal to, because I started with 0. Loop through those i's, and then I can, this is building on what I showed you before, I can pass in the variable I and say, first console log dog 0 to get spot, then console dogs 1, and we're pulling out the item in the array by virtue of stuffing in a variable that has a different value as we go through again and again. All right, that's me.
So I want to get into just a little bit of how JavaScript works, because this is, I think, one of the hardest concepts to get over when you're writing JavaScript versus writing something like Python or Ruby, where JavaScript, everything happens asynchronously. So lots of things are happening at the same time, and they're all happening out of order. And that's actually really great when you're writing stuff in like a web browser where you have users are clicking and they're filling out forms and they're panning around the map and lots of stuff is happening at once. But it's important to understand that JavaScript is only ever doing one thing at a time. It just does them really, really fast. And that stack of everything that JavaScript has to do is called the event loop. And the loop really works like this. We have a function, and we're going to execute that function until we're done executing it. And then we have another function, and we run that function next. And then we run that function all the way to the end. So I put together a little demo of this. We're going to crank this up until that doesn't go there. So I have a function called go, and we're going to start go, and the event loop at this point is empty, right? There's nothing on it. So we're going to say console.log hello dev summit. Cool. And then we're going to call another thing called set timeout, and this lets us delay the execution of something by a certain number of milliseconds. So in 100 milliseconds, I'm going to console.log let's learn. And this adds something to the event loop later. So this isn't going to run right away. It's going to happen in 100 milliseconds. And then we keep going. So now we set timeout again. We'll log JavaScript in 10 milliseconds. And we'll log async in 0 milliseconds. And even though it's 0, it still goes on the event loop because it's going to happen later. And then the last one, we're running this go function to the very end before we start on anything in the event loop. So the last thing we're going to do is we're going to log thanks. And then we're going to run the go function. And you can see how this works, right? Because the first thing that we did, this works fine. We're going to log hello dev summit. But then everything else happens out of order. So thanks, async JavaScript, let's learn. Yoda, I am, right? Everything is happening out of order, but it's all happening roughly according to time. So async happened 0 milliseconds away. So as soon as I got done logging thanks, the go function's done running. The event loop says, now what else do I have to do? I've got a console.log async, so I'll console.log async. Now I'm done with that. What do I have to do? I don't have anything to do. Now so I'll just wait until I have something to do. 10 milliseconds later, it'll log JavaScript. 100 milliseconds later, it'll log let's learn. So that's just something to give you an idea of how JavaScript is working, and it gives you kind of a framework for how this is gonna work for some future demos. So in terms of dealing with how JavaScript is asynchronous, there's kind of two primary methods, and you'll see them both used kind of interchangeably and a lot. And the first one is callbacks. And this is where a callback is just a function that's called later. So a lot of things, you'll supply a function as a parameter to another function, and it'll execute that function sometime later in your program. So a really common example of this is clicking on a button. We'll just go this. So I've got an HTML page, and I've got a button on that HTML page, and I want something to happen when I click that button. So in JavaScript, I'm going to just get that button, and we'll go over some of the how to interact with browsers a little later. But I'm going to add a listener for an event on that button. I want to know when something happens on the button. I want to know specifically when the button was clicked. And in order to do something when the button was clicked, I just pass a function to that, and whenever the button is clicked, I'm going to log the button was clicked. So this function is an example of a callback. I just want to supply something that will happen later. So if I open up the console and I open up the output, we have our button, and every time I click the button, it logs a message. So it's executing that callback over and over again every time the button is clicked. And eventually, callbacks are great. Like, you use callbacks a lot if you work in stuff like Node.js. That uses everything's callbacks. And eventually, callbacks started to get really kind of unwieldy, because you can imagine you might want to make a request for some data from a server, and then you need to process it, and then you need to do something else, and then you want to make another request, and then you've got to check if you have an error. And eventually, it started to get really difficult to manage, and there were all sorts of tutorials about how to deal with that. And eventually, a lot of smart people got together and they came up with this thing called promises. And instead of a callback, a promise represents a value in the future. And that value is going to resolve at some point and supply you with a value. So this is another little example using a slightly different API in the browser to get data. So I have a variable. We're going to fetch some data from an API. This is just I can make that bigger. That's probably about as big as I can make it without it getting really ugly. So we're going to fetch some data, right? This is just a random API that returns, JSON about users that is random. And the idea with promises is, instead of stacking all these callbacks, I just say then do this, then do that, then do this, then do that. And I just stack up this big chain of things that happens. So I'm going to fetch this user, then I'm going to process the response, then I'm going to do something with the user data, and at the very end, I want to make sure that I catch any errors that might happen in that process. Maybe the server's down, maybe I don't have any internet, maybe the Wi-Fi is really bad. We want to just make sure we can handle that, and then these are all just more functions. And the idea with promises is I'm just going to return the next thing. So we're going to fetch this, then I'm going to process the response, and I want the JSON value of the response. So turn that into this JavaScript object that I can consume. So take the text that I got back from the server, process it as JSON, which stands for JavaScript Object Notation, if you're wondering. It's just a fancy way of saying this is some text that looks like a JavaScript object. And then it's going to pass that into my next function, which is do something with user. So now I get the JSON back, and I can just print it to the console. And you can see that I have an object. It has info. It has results. The user has a cell phone. They have a date of birth. User's female. So you can see this just generated kind of a bunch of random data for me that I can use to demo this for you. And you'll see promises a lot in the JavaScript API. They're very, very heavy on promises. So, I think you've got an example later showing some promise stuff in the JavaScript API. So just to make you aware, that's kind of what they are. They represent a value that's going to happen in the future.
And I'd say the minimum thing to get from the last couple of demos and slides is some programming languages are synchronous. In Python, as you step through from the top of the file to the bottom of the file, everything happens in order, and that's great. But JavaScript doesn't work that way because it involves making web requests, because it involves user interaction. These are all reasons why things happen out of order. And just knowing to not trust top to bottom flow is like the lowest level sort of bit of familiarity, and the rest of it will kind of come with time.
Yeah. So this is another example of just a couple more JavaScript concepts that I think are kind of a little trickier to get a handle on. So if you want to, start writing your JavaScript and refer back to this at some point, every time you call a function, that function has a certain scope, and that scope is all of the variables that were around the function when you called it. So in this demo, I have a message, and then when I call go, I console log the message, but I didn't actually define the message inside the function, and I didn't pass it in as a parameter. The go function just knows that there's a variable called message around it and is able to read that just fine. And the fancy word for this is it's called lexical scope, and if you answer that in a JavaScript interview, you'll get hired. Because some people are weird and they're like that. And this actually turns into a really powerful concept in JavaScript because we can do, the other $1 million word from this is you can create a closure. And do my separate demo of this, is you can have functions that return functions. And this is, I have a function that's going to take an amount that I want to add. So say I'm making a really simple little calculator app, and I'm going to return another function. And then I can create new functions. So I can make a function that adds 5, and I can make a function that adds 10. And then when I call add 5 to 1 and add 10 to 1, those individual functions remember the amount to add that I passed in, because that was in the scope when I created this function. And it's different for every function. So this is something that you'll run into a lot. And you'll hear people talk about closures and scope, and you'll know what that means now. Just know it's a way to kind of contextualize and contain all of your variables. So the last thing, and this tripped you up a lot when we were kind of thinking through JavaScript stuff a couple years ago, is what is this? And you'll hear a lot of people have opinions about the special JavaScript variable called this. This is the context that the function is executing in. So if I have a user, this user is Casey Jones, and we have a function that generates their full name, instead of referring to user inside of this function, I can refer to this, because the full name function is part of the user object. So this is just the context that the function was running in. And then this actually changes depending on how the function gets called all the time. So this is kind of where, no pun intended, this is where people have a problem with this. So if I go back to my old demo, I'll just close out the console there for a second. If I go back to my demo, if I have a user and I get that user's info, this is the same demo as before. I'm going to fetch some data from the server for this user. And then I'm just going to say, OK, now I have a function. And then once I get the user's info, I'm going to set this.email because I'm calling get user info. So we're going to set user.email. And then, so we're going to get user info. And then we're going to console.log this. Does anyone know what this equals? This is like a trick question because it never equals what you expected. So if I run this, this doesn't look like my user. This actually isn't my user. This is the global JavaScript object that always exists in the web browser, and it's called window. So it represents the entire window that you're working in. And because when you do those anonymous functions, like what John was saying, when you create a new function, the default this is always window. So it changes depending on where you are in your program. So be aware of that. You might just want to occasionally console.log this and make sure you're in the right context if you're using it. And there's a couple ways you can manage what this is. And I'm going to show the two popular ones that I use all the time. And one is there's a new way you can call and declare functions. Man, got to figure out how to make this go away. So I'm going to do the same function. This is the same demo as before. And the only thing I changed is I changed how I declared this function. I used this different syntax with the =, arrow. And we called the shorthand for this is arrow functions. So usually, arrow functions are just kind of a shorthand way to define a function. But the special thing about them is they don't redefine what this is. So this is always the same as whatever the this is from your last function. So the this inside of this little function right here is the same this that I get for the entire bit up here, which is user. So now the entire thing works. So when I console.log this, run that again, you can see it actually, this looks like my user, their email is undefined because I probably messed something up. The second way to do that is to call function bind. And bind is a method on functions that you can call. And it says, whenever this function is called, this is what this is. Always execute with this equals user. Just do it. I tell you what this is, be really explicit about it. And you'll see lots of variations of bind. Dojo has its own version of bind called, I think, hitch.
Yeah.
I think it's Dojo hitch. It's part of the language module. So you'll see all sorts of people doing different things where they're just saying, make sure that this equals a certain thing inside this function. So don't get tripped up. Just console log this occasionally. Now you've got some tools to deal with that.
All right.
So now we've kind of gone over kind of the fundamentals, and I think that's kind of the bulk of the talk. But I'm going to flip back and let John kind of talk about developing a JavaScript application and like setting some stuff up.
So if you were eating up everything Pat was talking about, that's great. And if there's still some question marks floating around, that's all right too. I think the last couple sections, this idea of scope and these are things you'll come up against, but APIs do a lot to abstract away some of that complexity, and some of the topics Pat was bringing up are their best practices, and when you want to write modular, shareable, portable code, you deal with it. But when you're really getting started with JavaScript, you don't have to tackle all that stuff right off the bat, and you can get away with murder creating global variables and then just hoping they don't bash into each other, and you'll be fine a lot of the time. So don't worry about any more than that. So we showed all these concepts, we've showed some demos, but we never really have yet talked about this idea of how to get started on your own machine, set up your development environment. And the good news with JavaScript is you've already got the browser, you're already comfortable with using the browser, and the idea is we just want to run some JavaScript code and a web page on our computer. So we don't need to, I've talked to so many folks who start writing a little JavaScript and they're pushing it onto some other remote computer that the IT staff said is the web server, and they're making mistakes, and that's fine, but they're making them slowly because there's so much lift in moving the code around. You want to work on your computer, and you need to be able to say HTTP localhost or whatever your machine name is, and in order to do that, it depends on what type of OS you run, but there's lots of different options. If you use a Windows box, IIS is the web server that's built into Microsoft. You just have to turn it on. If you use a Mac, Apache's built in, and some people use Apache. They're kind of big web servers. There's also other options. You can use Python and run a Python command to just have Pythons turn on a web server for you. And all that means is share a folder so that when somebody uses HTTP and opens the HTML file, they don't open it in the text editor. The browser opens the HTML file or the JS file. So I wrote a little gist, and there's a link if you don't know whether you have a web server running or you want to set one up. I've got Windows, Mac, Python, Node, some help here. That's the reference material. At the end of the day, you just have to have HTTP. In this case, I'm running a Node thing because I thought that would make me cool. My girlfriend told me that was not true. I found out after the fact that it was already too late. So in this case, I'm using port 8080 because that's what Node is running. But IIS, by default, it's port 80, which means you don't have to say :number. You just say localhost. And when you use IIS, you just put your HTML file in the new folder on your computer, C drive, inetpub, wwroot. If you put an HTML file in there and you go to localhost and open that file, it'll run. So in this case, I've got my text editor of choice is, for today, is Atom. And this demo.html file, you'll find lots of samples all over the internet of one-page contained stuff for you to play around with and run yourself and break and change. So copying that onto your computer, saving it in a folder, whether you do an HTML file and a JavaScript file that are linked together or you do all in one, you save that, you know where it is, you make sure your web server is running, and then you have it here. And I'm not going to do anything other than open up the developer tools here. Chrome has them. Firefox has them. Back in the day, everybody used Firebug. I don't know if that's still the thing. What's the other browser? Safari has developer tools. IE and Edge have developer tools. This notion that you want to not only run it locally, but set breakpoints, inspect things. This is where your eyes and ears are in terms of how it's running. So your development environment in JavaScript this is where you run it, and there's intelligence built in and tools that you can use to get more insight. And the text editor is where you make a file change. So, run it, find a bug, go back to your text editor, try to fix the bug, save, refresh the page over and over and over and over again. That's how JavaScript debugging and development works. The only other thing you'll probably have open is some documentation, whether it's generic JavaScript or like the JavaScript API doc that's guiding you in how you write your code and examples that you're stealing. That's the tripod of success. In a JS development environment is a text editor at a minimum, a browser, and some doc.
So now that you've got a basic web page set up and you can develop, you've got some JavaScript set up and you've got your text editor and you know some JavaScript, the next thing to learn is the DOM. And the DOM is the document object model, and that's the glue between the HTML that you're showing to the user and the JavaScript code that you're writing. So all of those HTML things that you're writing, those have a representation in JavaScript that you can mess around with. And usually you'll do the same pattern. You'll find certain elements that you want to do something with, and you'll listen for things to happen to them, like a click or a form submit, or the user typed in an input, or they hit a key, or they double-clicked, or they right-clicked. Or you'll want to change how some of those elements are work. You want to change the text that's inside them. You want to remove them. You want to add to them. You want to change things. So I took the form that John did, and I just brought it into JSBin because I didn't even want to bother with a local web server. And this is the same HTML. We've got a style sheet here that we're going to load from Amazon. It's the calcite web styles that we're working on at Esri. And then I just made a little form. And this is pretty much a standard HTML form. It's got an action, a method, it has labels, it has inputs, and the user can type in the inputs. And right now it doesn't do anything. So what I need to do is I want to add some behavior to this form with JavaScript. And I put a little results down here. So when I fill out the form and hit the submit button, I want to put the value of the form in the results. So we're a little short on time, so I'm going to just flip to the finished example straight here. And we'll just go to the JavaScript and pull up the HTML too. So the kind of the base of how you would work, and this is if you don't want to pull in any other tools, we're going to keep it really basic, is you're going to start with document. And that's your HTML page. And we want to do document get element by ID. And that ID is the attribute ID that we put on our form. So I added that so I can select that with JavaScript. And then I can save the reference to that element as a variable. So now I have a variable that represents this HTML element. And then I can listen for events. So I want to know when someone submits this form. So I want to add an event listener, and I want to listen to the submit event, and then I want to pass a callback. I should really call that event to make that a little clearer. So this callback function is going to be executed whenever a user submits the form. And I get some information about the event right here. So now I'm using some other APIs, and you can go look these up. If you just type it into your browser, you'll find the documentation for the things that I'm going to show. So I want to make a new form data object, and I'm going to use the event target. So whatever triggered the event, I'm going to turn that into some form data that I can work with in JavaScript. And then I'm going to create an empty object. So I just want a blank thing that I can store some stuff in. And I'm going to loop over, there's this for each property that's a part of form data. So for every item that I got in the form, I'm going to loop over that, supply another callback function that's going to be executed for every time I get something in that form data. And I'm going to populate this data object. So I'm going to say data, and then I'm going to say there's going to be a name, And then the value of that is going to be formData.get, and it's going to be the value that I put in. And this corresponds with the name of the input and the value that the user typed in. And then the last thing I'm going to do is I need to put that in the results. So I'm going to get my results element, which is all the way down here. So I've got a results element, and I'm going to get that by ID 2. There's other ways to get it, but this one is the quickest and the easiest to show you. And then we're going to say the results and the text content of the results, we're going to dump some text in there. And we're going to say, I just want to turn this data object that I built up of all the values into a string. So that's JSON stringified. It says take a JavaScript object and just turn it into something I can look at. And then the final thing we do is we say, whenever you submit a form, by default, what that form is going to have behavior. It's going to try to actually like send a post request to a web page with the form data and reload your whole browser. We don't want that to happen. So we need to prevent the default thing from happening. This is the same thing if you have a link with an href. If you don't want the browser to go visit that link when a user clicks on it, you can call prevent default to stop whatever the browser is going to do from happening. So if I look at my output, if I type in, I'm Arlt@Esri, yeah, that's fine. Test, and then I submit that, I can see that I now got this little, oh man, you can sort of see it. It's that little JavaScript object right there at the bottom. So that's actually the data from the form, and I pulled the data out of the HTML, and I turned that into a string, and then I put that string back into the web page. And there's dozens and dozens of APIs for doing this. The DOM is one of those really, really complicated things. It's probably the hardest thing to learn about building a web app. JavaScript compared to the DOM is totally easy. You definitely know enough JavaScript at this point just from what John went through in the first 15 minutes. That's 90% of the JavaScript that you use on a day-to-day basis. The problem is actually that the DOM is really complicated, and the glue between the JavaScript and the browser is what actually takes all the time to learn. And that's why people created tools like jQuery and Dojo, is to make that layer a whole lot easier. That's kind of their purpose. So learning the vanilla, like no frills DOM APIs is a really good way to get started. And we've got some links at the end that'll kind of point you to the right resources and stuff to get started there.
I'd say we just blast through the JS API sample and then save all the time for the outro.
You just want to go straight to that?
We're pretty short.
We're running short, so we're going to skip. I will point out one more thing that before we get to the JS API. You'll see this in every JavaScript API presentation, so I wanted to talk about it because you're going to see it and you should know what it does. When you're sharing JavaScript code as you build things that are more and more complex like the JS API, it becomes better to modularize your code. So break code into smaller pieces and share those individual pieces. And as we built more and more complex JavaScript applications, we need ways to manage all of the dependencies between the different bits of code that we have. So that's where you get a lot of things like module standards and formats and things like that that come in. So when you see the require statement somewhere, when someone calls that require when they're showing you the JS API, that's part of Dojo, and that's saying, I need to go get these other modules before I can run my callback function. So I need Esri map, and I need Esri views map view. And then those get loaded by the browser. Dojo does all the heavy lifting to load those modules. It knows where they live. It knows how to load them. It loads them into the browser for you automatically and then runs this callback function and says, now that I've loaded this stuff, now you can work with it. So I just wanted to, that's like the one essential piece.
No, that's perfect.
So you want to flip back to, John's got 2 demos just stepping through some JS API code.
I think we probably only have time for one of them, but we're going to try and put all this together. So how many of you guys, your first experience with doing any JavaScript work was with the Esri JavaScript API? Okay, so some yes, some no. We want to talk about one of these samples in line just to see how all these pieces fit together with the JavaScript API. And for me, this is the first way I ever learned JavaScript. And this is just a live sample. This is from the developer's website. So when I told you before the developer tools were great when you were running your own website, they're just as great when you're just being a snoop on other people's websites, as long as the code's not minified. This is a one-page JS API sample that's meant to demonstrate sort of how the JS API works. And we can debug this and set breakpoints and learn a lot about how it's working, even though we're not running it. So what the way this works is, it is a 3D scene. It's got like some of the big mountains, and it allows you to interactively set up a clause to figure out which ones are going to draw. So that's how it works, in practice. Let's see how the code works. So here in the Sources tab, I can click this index.html and see this one-page sample. And there's a couple hundred lines of code. We're going to kind of step through it though and hopefully make it a little bit more digestible. So up here at the top, we use a script tag to load the JS API. But like Pat said, since the JS API has a lot going on, we have a little more complicated architecture here for deciding what stuff from the JS API we want. So these are all the classes that we care about. And there's some Esri stuff and a couple of Dojo modules. And the whole of our JavaScript is all wrapped in a callback that waits until the resources are there. So we go out and fetch the source code that helps us. When we get it back, this method takes an array here. So this is one of those arrays. Then there's one of these anonymous functions. And the arguments that are passed to the function correspond with the classes in the API so that we can use them only in the callback. So this is a best practice in JavaScript to not pollute the global namespace, but it makes it more complicated. It's a little harder to wrap your head around when you get started. So if you made a global variable or did something else, you only have a map in the callback. And that's a good thing, but it makes it a little bit harder to deal with when you first get started. So here's the code. Peaks URL, this is a feature service that has some of those mountains back behind it. We're going to query against that. Since we have pop-ups here, there's a little shortcut here that sort of helps us set up the pop-ups, tell us what fields we want to be in the pop-up and what we want the formatting to look like. And then we create this point symbol 3D layer. We decide that we want to use a cone, so we can look in the API reference for the syntax of how you create these symbols. Then we have an empty graphics layer. We use our variable results layer to instantiate that object, but there's no graphics in it yet. Then we make a query task and we pass the URL of that service that has the mountains. Afterwards, we want to set up what the query is. These parts of the query are standard. We always want the geometry. We always want all the output fields. So part of that is static. Then we make our map. We use OSM as the base map. We'll do a 3D thing. Here's a scene view. We decide how far we want to zoom out and where we want to be centered. Here, inside the callback, we do the same thing Pat showed off before, where we grab an element by the ID. And Dojo has a sort of another way to do this, but there's just different ways of doing the same thing, and JavaScript's quite a bit like that. These are going to help us grab the value, whatever's currently in one of these input boxes. Then we've got this function, do the query. Like I said before, this is us declaring it. And what doing the query means is removing the other graphics, setting that where clause so that we figure out which mountains fit the criteria that are currently in the box. Then we execute the query task. But down here at the very bottom, we have to actually decide when we want to do the query. That's hooked up on the button click. So the query function doesn't actually get called unless somebody clicks on the button. When we do the query, we execute. This is an async thing. We need to make a request to the web server. So if you look at the network traffic, if I go back here, I can see, if I scroll back a little ways, because I think we zoomed in, there's a bunch of tiles. I think I just need the AJAX ones. How do I do XHR? Here's our query. This is that request we made, and that took a couple of milliseconds. This gave us back JSON, but this is the part of the developer tools that just tells us about the traffic. Then we do this promise thing where once that promise is resolved, we get the results and we handle the error. So here's another function. This happens in a chain asynchronously once it's ready. With the response from the query, once we have the mountains, we're going to do, this is another Dojo thing, but we're going to map through that array. And we're going to take the features originally they only have geometry and attributes. We're going to add the symbols so that we can draw them the way we want them to look here. Add that as a new property, then we're going to add them to the graphics layer. So if I set, the breakpoint here, I could hang out in this all day, but I've got to actually fire the queries, change the value, click the button, wait for the result, get the response. Now I can set this breakpoint gets hit, I can see what the variable represents. There's a lot more information in me digesting this code that somebody else wrote. I have a lot more tools when I'm looking at it running than when I just look at it sort of on the developer site. So that's all I wanted to show off. We got 3 minutes for a wrap up.
Let's wrap up. I'm going to just burn through some stuff. There's a new, last year, man, you're good at that.
I apologize.
If there's every year JavaScript releases now a new version of the language specification. The one that they released last year, which was called ES 2015, that added a ton of new features to JavaScript. So you saw some of them that John and I did. Promises is fairly new. The arrow functions is new. It updates every year. And the good news is not every year is as big as 2015. There's only 2 new features in JavaScript in 2016. There's only like 1 new feature in 2017. So I recommend if you're gonna pay to take a JavaScript class or anything, only pay that person. Refuse to pay if they don't teach you ES 2015 at least. This is a huge time saver because it's the way that everything's going. I will say this, I have 2 other slides, I'm gonna skip those, but in terms of being a beginner in JavaScript, you don't know what you don't know right now. And that's actually even better than knowing what you don't know, which is the boat I'm in. You don't know React, and that's actually great. You can go ahead and write your UI without pulling in React. And if your application gets to the point of complexity, then maybe it's time to start learning something else to help you make that less complex. So this is, I mentioned this article earlier. This is how it feels to learn JavaScript in 2016. It's easy. Just code it all in TypeScript, use modules with fetch, target ES6, transpile them with Babel, so on and so on. We have very different definitions of easy. This is how not to learn JavaScript. This is like the worst way. This is the better way. Adi Osmani is a product engineer at Google. So he knows his stuff, right? Like I follow him for advice. First, do it. Write your app. Just do it how you know it will work. Make it work. Then focus on doing it right. Maybe say, this part's a little confusing, this part's a little complex, I'm going to go back, I'm going to make my code a little better. Then keep doing it better than that every single time. But the first thing to do is make it work as fast as possible and iterate as quickly as you can. And only pull in more stuff and more tools when you feel you're really going to get a benefit from them. And once you really have that basic knowledge. So this is some of our collected resources. MDN is Mozilla Developer Network. It's the Firefox Developer Network. That's kind of the best source for all the documentation. They have a whole Learn Web Development section, which is really, really nice. You Don't Know JS is kind of the new, if you were here last year and you saw Douglas Crockford speak. JavaScript, the good parts, isn't quite so up to date now. The You Don't Know JS is really kind of the new JavaScript, the good parts. And the focus of You Don't Know JS is kind of what John and I have been talking about. Learn the fundamentals really, really well so that you can make informed decisions about what parts of JavaScript you want to use or not. So
yeah, don't get down. The landscape is complicated. Don't get down on all of the distractions and noise. Just have fun with it. Stick with the folks who are not trying to sort of make it out to be any wilder
fill
than
out
it is.
a feedback survey, please. We're obviously over on time, so we need some feedback on what to cut from this for next year. So we got about 10 minutes that we probably need to trim out of this at some point. So please leave feedback. It's on the Esri Events app. Just search for JavaScript for Geographers. We'll leave this up for just a minute or two, and if we do questions,
just come on up if you've got questions.
Come on up if you have questions. Yeah, thank you.
And thank you for coming.